generate my assembly, generate my parts. Everything is tied back to this part in this sketch, so that when I'm ready to make modifications, I come back here. Very nice, easy use of the new tool and new functionality. Okay, so let's take a look at sketch blocks. This is how hard it is to create sketch blocks. I go through and I'll generate my geometry, and I'll dimension it. I don't have to dimension it, but I just want to point out what it takes and that it can actually handle not just what you're doing as far as the geometry, but it'll handle dimensions and constraints as well. So let's do a constraint here. Have that come there. There we go. And now, create block. What do you want to call it? I'll just call this test ALACAD. The geometry I want to turn into a block is going to be this. I can add an insertion point, I can add a description, highly recommended, and select OK. And you'll see it's added a folder called blocks. There's the name, test ALACAD, and under sketch there's even a test ALACAD. So I can even bring instances of this in. Just grab this, drag and drop, there it is. And look, it's treating it just like a block, just like it would in AutoCAD. Okay. Can even dimension between them. Parametrically dimension between them. Very nice, very handy. If I need to edit them, I can right click and edit block. And now let's just add a quick little triangle to this. Finish editing block, and you'll see it not only updated the one, it updated both. Sketch blocks. Very nice, very handy. I can even create nested sketch blocks. Come back and edit our sketch. And I've got two of these. And I'll create a block, and we'll call this test nested ALACAD. What do we want to use? We're going to use all that. Now we have a nested block. So drag this in here. And look, I've got a nested block now. So I can quickly create my sketch blocks, bring them in, use them, simulate what I need to simulate, take a look at how they're all going to work, and utilize them from here. When I'm done and I'm ready to turn them into parts, my make components goes back and actually does the exact same thing as it did with multi-body. I can turn these into parts and assemblies from here. So let's take a look at finite element analysis. What I want to do is show you the assembly part of the finite element analysis. Right here you can see I'm in an assembly. I'm ready to go and start playing with stress analysis. I go to environments, stress analysis, no conversion, no nothing. I'm ready. Now with this new environment, I also have the ability to create multiple simulations. So here I'm just going to create a single one. We'll call this first run. And note that even though I've got this one, I can create multiple ones, and I'll show you that in just a second. Again, with everything else, I go through and verify my materials. So note, even though materials weren't defined originally, I can go through and define them. This was all shown on another webcast, but I'll go through and quickly show you. Notice, it recognized the other three instances of the washer and immediately applied those to those. I didn't have to go through every piece. Material set. I'll go through and place a fixed constraint here and here. A force constraint on that face in that direction. And 100 pounds. So I can even have control over local mesh. So I can do a mesh view, but I just want to do a local mesh control right here because I'm concerned about high stress concentration. Notice I can quickly go through here and specify how big I want stuff. I can control the mesh just in this area. So I'm going to mesh it real fast. I've got a really nice mesh. I needed a higher mesh in this area. I did not have to do a whole lot. All I did was refine the mesh in that area. I can even take and have parts and I can exclude them from the simulation, so that when I'm ready I can take control of all this. Now, one of the important things to note is contacts. In this area I have contacts. So let's take these two. It's considering them all bonded, basically treating them as if they were all welded together. Those two contacts I wish to slide, and I'm just going to run a quick simulation. There's our simulation. Real quick, real fast analysis, much better visualization. I still have on Mises, displacement, and safety factor. So I can still go through all this and determine those areas that I need to. Now, what if I wanted to take a look at doubling the force or moving the low force location? Instead of having to go through and change those and lose this information, I can literally come through here, copy simulation, and look, I can now take this, rename it, and now I've got a second simulation. I can go make whatever changes I need to make, rerun the simulation, and go through and determine what needs to be done. I can also go back, and before I'm done, I need to do a convergence test. With which ones I can specify the number of refinements, the stop criteria, so I have much better control over my information. When I've done doing my refinements and simulate it again to rerun the analysis, I can generate my reports. So now let's go through and take a look at a few things with assemblies. Let's take a look at Content Center. And I'm going to come up here and say place from Content Center, just so you can get an idea that it does open a little faster. You do have access to everything you're typically used to using with Content Center. Again, with desktop content, it's just a little faster to access. Okay? Nothing different. Okay. Now I'd like to talk about folders and assembly folders. So here I've got this nice assembly, and what I'd like to do is break this down into a couple of categories. So to do this, what I can do is right click and create new folders. So I right clicked on this top one, so I create new folder, and we'll call this so you can see it's got a different icon, looks like a little folder, and now I can just come through, highlight what I wish, drag and drop, and it moves it under there. So real fast you can come through and get control over